Welcome to the Application Delivery How-To video series. My name is William Stoneman, and today we will cover the topic of how to upgrade an Navi cluster using vRA vRO. During this video, we will focus on the vRealize Orchestrator workflow. However, this workflow can easily be incorporated into vRealize automation blueprints if desired. This workflow will also augment the implementation as prescribed in the Advanced Load Balancing VMware Cloud Foundation solution. Before we look at the workflow, let's get an understanding of what is required to successfully upgrade an Navi controller cluster. It is important to have an understanding of the impact of a cluster upgrade on virtual services. Virtual services are non-disruptive during SE upgrades, with one exception: Elastic HA in N+M buffer mode, or HA mode, where a virtual service is placed on a single SE, will experience an outage as its lone SE is upgraded. You may scale out the virtual service so that it will utilize multiple SEs, however, this has licensing implications. If your environment is designed with an HA model of N+M buffer mode, the best course of action is to schedule an outage window. The first step we need to do is to decide on the upgrade path. We provide upgrade base packages that consist of major version releases. We also provide patch upgrade packages by which hot fixes are placed into effect. Therefore, we have three upgrade paths that we can select from: base only, base and patch only upgrades. Once the upgrade path has been selected and the upgrade packages have been collected, we must now upload the packages to the controller image repository. At this point, before the upgrade is started, it is highly recommended to take a remote, one-time backup of the environment. This is in case the upgrade fails and a configuration restoration is required. We are now ready to initiate the cluster upgrade by specifying the image from the image repository and determining the action to take in the event of an SE failure. We can either continue the upgrade or suspend the upgrade. Either way, this will require manual intervention to resolve any service engine issues. Once the upgrade has been initiated, it is very important to monitor the upgrade progress for any controller or SE errors or failures. Within the workflow, we will need to automatically upload the upgrade packages, as well as add additional checks and verifications along the way. Now let's take a look at the vRO workflow. In this workflow, we are utilizing curl commands to execute the API calls to upload the upgrade package files. Since the package files are several gigabytes in size, we are unable to utilize the vRO built-in meme attachment feature, as its file size limit is 8 megabytes. This process requires a remote Linux server for us to run SSH commands through. In our lab setup, we are utilizing the vRO appliance itself. To utilize this function, we need to update workflow variables with information for the Linux server. If the local vRO appliance is used, you must specify the IP address or FQDN and not localhost. The variables that need to be upgraded are SSH username and password, as well as SSH host, SSH path, and SSH port. Next, let's take a look at the input form. I have pre-populated the fields with the required settings for my lab environment. For this demo, we will be upgrading a Navi cluster from 20.1.6 to 21.1.2. First, we need to select the vRO controller connection object and specify the admin password. As for the one-time configuration backup, the workflow will collect the backup file and save it to the vRO appliance. Therefore, you are required to enter an encryption passphrase, as well as the destination directory of the appliance. Next, we need to specify the SE error recovery action. As described previously, we can specify to continue the upgrade or to suspend the upgrade. In our case, we will select to continue the upgrade. We will then need to specify the upgrade type, and since we are upgrading from 20.1.6 to 21.1.2, we will select Major Release Upgrade. Finally, we need to provide the location of the base upgrade package and the upgrade version. In our case, the upgrade file is located on the temp directory of the vRO appliance. Before we execute the upgrade, let's take a look at the environment. We only have a single virtual service configured, and as you can see, it is only utilizing a single SE. When this SE is upgraded, this virtual service will be impacted. We can scale out this VS so that it will not see any impact, but as this is a lab environment, it is not needed. Now, let's execute the workflow and watch the upgrade in action. The first thing that it will do is upload the upgrade packages. As this process might take some time, we will fast forward through these steps. The packages have successfully been uploaded to the AVI controllers, and the backup file has been saved to the vRO appliance. The upgrade has initiated on the AVI controllers. Now let's pause again and come back when the SE upgrade has initiated. The controller node upgrades have completed, and we have moved on to the service engine upgrades. As you can see, there are 2 SEs being upgraded, and the status in progress is being displayed. Let's fast forward again to when the upgrade is complete. The SE upgrades have finally completed and the workflow was successful. Let's log back into the AVI cluster and validate that we are running 21.1.2. Let's navigate to Administration, Controller, System Update. And as you can see, we're running the correct version. Thank you for watching. Please check out the other exciting videos in our application delivery how-to video series.